So now in this example, we are going to use live script of MATLAB to plot a vector field of this system of equation and then plot some solutions in the vector field corresponding to these initial conditions. So this is just a revision of an earlier video whose link I have included here that I had posted for you about a couple of years ago. So it's just a slightly different example that we are going to discuss. But in case you want to see the details of the commands and scripts that I write, all right, you may refer back to that video, okay? So to open a new live script, when you go to MATLAB command window, just click on this new live script. So first we shall create a set of values for the coordinates to do the calculation set, and we are going from -2 to 2. So let's go in the steps of 0.2. You can change it if you want. Okay, 0.22, and now this will suppress the output, and then we should take the component u as, and we are putting a period before the operator to do component wise multiplication. All right, so what I'm doing is I'm just entering these expressions, and then v is going to be, there is only one change, so I'll just do this. I don't know which one would be faster. That's okay. Change this to -x, and there we go. Now I'm calculating the length of each of the line segments because that will, give us a unit vector. So let's square the components and then take the square root of the sum. Okay, so there we go. And now you know that quiver is going to give us the vector field. So we got this at xy. We will just plot those line segments of equal length, and we are going to say x is equal, also type for, and now what we have to do is that we have to press Control Enter when we are taking the output from a live script. So I'm doing Control Enter. So it should give us a vector field, which it did. And if you did this, that is just click on this arrow, it gives it to you, in the MATLAB figure window where you can go ahead, edit the, like you can go to figure properties and do a lot of editing in a way you would like. All right. So now what we are going to do is that we are going to write or draw the solutions with respect to these initial conditions, and let's hold on to the same window, and then what we would do is that we shall create a function handle. So we have f at tp. So what we are doing is this. You know that we have x and y as functions of t. So instead of x and y, what we are doing here is this, that we at t, we are taking a vector p, and instead of xy, we shall use P1 and P2 as components of P. So what I'm going to do is, remember here we have x, y. So for y, we will write P2, and then we have times, then P1 for the first component. So P1 is square plus P2 is square minus 1. So this is my first component, right? Okay. And then for the second component, let me take it to the right and then I'll bring it back. Then for the second component, we have the same thing with just a slight change, that here instead of P2 we have negative P1, right? Okay, so and then we are suppressing the output, and then what we are going to do is this, that we shall create two vectors, for one for the initial x values and the other one for corresponding initial y values. So these are, you can see, 0.25, 0.5, 1.1 and 1.2. So that's what I will write, and B is, again, in this case, these happen to be the same values. They may not necessarily be. So I'm simply copying and pasting them here. All right. Now we shall write the instructions that we have. See, we have the four values for the initial point. So we will say for k from 1 to 4, what we are going to do is that for values of t, we shall create approximate solutions by using the ODE 45 feature. Okay, so we are giving to f, and then what I'm doing is, let's take 0, 5 as a range of values of t. Okay, this value t here, and then we want to tell it that to take the initial values as a, k, b, k, and we know that, that is from k goes from 1 to 4. And then once we have gotten the approximate values, what we are going to do is we are going to ask it to plot the approximate values, first x coordinates, okay? So here, and then we have the y coordinates, okay? So there we go, we got 2 here, right? And then we shall say for line width, okay, let's just go with, we can go with 2 or 3, all right? And let's see what it gives us. So we gave the command and we shall press Control Enter, okay? And the graph should be in here somewhere. So we have the graph, but we do not have the have complete graph in here. So we can do this, take more values of this guy t, say, let's go for instance, 20 values, see what it gives. Okay, it gives us a complete graph. And again, as before, you can go ahead and click on that arrow sign that will give you a plot in the in the MATLAB window where you can edit and play with it. All right.